All right, guys, let's bring it in real quick. So, for those of you who were not here on Tuesday, what we did was discuss what's going to happen with the course. We're starting off with a very environmental analysis-based sort of understanding of what computational design can do for you, and algorithmic modeling or visual programming, whatever you want to refer to it as. And we talked a little bit about the different forms that takes, what the underlying structure is, and then we started to explore it a little bit. So our first exploration is actually going to be to construct a very simplified orbit of the Earth around the Sun, and then look at what that actually means for understanding shade and shadow and the different seasons of the year. So all of these environmental implications that we're going to be looking at throughout our time studying architecture and hopefully designing architecture as professionals in the future. So what we did Tuesday, to put things very short, is we looked at how do you construct points in space, what is the user interface, how do we actually process information, input information, and connect these components together. So what you see here, we started off by creating a point at the center point of what we're calling our universe, and you see it right there, it's green, and that's what that is, that's green, and it's at 0, 0, 0 for the x, the y, and the z. On that point, we created a sphere, and that sphere is parametric, so we can make it larger and smaller, but for our purposes, we're just pretending that this is sort of kind of the sun right now, so it's just going to be semi-large. We also created a point that was 10 units away from the origin point of our, did I say universe? I meant solar system. Origin point of our solar system. So that one, we changed the x input to a 10, and so that's why the sphere that is attached to that sits off along the x-axis 10 units. And then we created a rotator, and that rotator is used to... oh, I'm on the wrong screen, aren't I? I'm using the wrong screen to show you things. I'm not used to this yet, guys. Sorry. The first point is there, and the sphere is this one, and that is the center of our solar system. And then the point right here is 10 points, or 10 units off of the origin point of the solar system. So that's where we placed our Earth. And then we created a rotator. So this part right here is our rotation, where we looked at what's the mathematical relationship of degrees per day. So 360 degrees in a full revolution around the sun, divided by 365 days in the year, gave us a slightly less than 1. What? That ain't it. Slightly less than 1 degree per day. So when we set up a slider for 365 days, now we can actually rotate around the sun all the way around in one full rotation up to 365 days of the year. Okay, and as a recap, the rotation functions in Grasshopper are reading it in radians, but the really powerful thing here is that we don't have to do the math to solve for radians what the degree equivalent is. So it just automatically converts it into radians for us. Okay, so that's a recap of Tuesday. As I go forward, I'm going to be showing you guys and talking to you a little bit more about the types of geometry we're going to be using for these exercises. And it's very, very important to understand them and have a working knowledge of what properties they have, most notably vectors. Okay, so how many of you guys remember vectors from like physics class, right? You do?
Barely.
Barely? All right, so in Grasshopper, well, let's actually develop something and then we'll get there. Let's see here. Let me grab what I need. All right. So, so there are two things that are going to come into play here. The first of which is vectors, and the second of which is we're going to have to look at how to keep this thing organized. You know, so if any of you guys have seen the really crazy Grasshopper definition, so I'm just going to see if I can find an image of one. This is really kind of tame, to be honest. That's not really all that bad. Yeah. I mean, you're going to be doing some wild things with these, right? So imagine if you're not controlled about what you're doing, these types of things can get out of hand really, really fast, right? And already the spaghetti that we're generating, you know, is kind of disorganized, right? Because I have crossing wires, I'm not sure. Do I place this thing, you know, in line with the top one, and then everything else leads to it? Do I put it in the middle? Do I put it at the bottom? You'll find your own way to kind of organize these things, but what I'll say is that I try my best to make sure that I've got separate ideas kind of blocked out and separate from one another, and then where they tie in, there might be a little bit of a gap to get there, okay? Another thing that I sometimes do is I'll take my mini groups and I'll create them, I'll create sort of secondary groups around them. And I'll refer to these, and I'm very particular about the language that I use here. I usually refer to these as ideas. It could also be called a statement or an action, right? So an idea is basically like you're putting together a sentence, right? It has to have a beginning, a middle, and an end, all the different grammatical components that make up a complete sentence, right? So if we're trying to create a sphere, that sphere needs a base point and it needs a radius. So attached to that idea or that statement, I have my radius and all the information that's necessary to create my base point. Okay, so I try to keep these things neatly organized in that way. It doesn't always work, but that's just a start. Okay, so I didn't want to intimidate you with all the crazy organization things, but I will sort of show you, I'll start to introduce to you a few file management things as we go along. Okay? Any questions so far? Yes? A group, Control G. Yeah, and to ungroup, you can select the group like this, right click, and say ungroup. I'm sure there's a hotkey for it too, I just never bothered to find it. Okay, so let's start generating our first thing here. Whoa, that's too low. All right. So what I want to do here is I'm going to, I introduced the term to you, the term vectors, right? So we're going to start using vectors as a way of mapping geometry into an oblique plane, right? So we're going to actually take the north and south pole of the planet and we're going to tilt it onto the angle of declination that our planet actually exists on. So to do that, we need to rotate around certain values. But to get started, what I like to do here is start with establishing the plane. Okay, the plane is the most important part. So we need to assign a plane to a particular place in space. And so rather than working on the new sphere that I've created over here, I think it's probably best for us to start to, and I say start to because it might change later, start to construct everything at our base point, okay? The reason I say that is because the base point that I've established for the origin of the Earth in its rotation is where everything is aligned to the world grid. So it makes things a little bit easier, right? I can establish, going up onto the vector tab and the plane panel, I can establish an XY plane exactly where the Earth actually is. And for me right now, I know that that's going to be in the same orientation, right? I look at what that plane has given me, and the green axis, which is the y-axis, is heading away from the sun, and the red axis here is directly aligned with the sun. So I have some alignments there that I can use as a basis.
Can you do that one more time, please?
Sure. Under vector and plane, it's the XY plane. Okay, so that XY plane is actually going to be sort of a very, very important thing for us. So what I'm going to do is establish that XY plane as a separate idea that completely detaches it from the original sort of exploration here, right? This is just setting up all of the Earth basis point geometry information. But I want to take this apart and sort of start an entirely new thing. So to do that, we're going to pass through some information using a wireless connector. Okay, it's pretty cool. All right, here we go. So the coolest thing is, if you look at the XY plane, right, the origin is actually a point. And remember when I introduced to you the idea of params? They're empty parameters. They house information, they pass through information, or they're used to read information. We can also use that as sort of a trigger or like a sign in a way, you know, like a direction sign or like a street sign to where information is going, even when we can't visually see it. So a cool little trick is if you want to pull something off, you can, because you know this is a point, right? You hover over that, it says that little X in the black hexagon. That's a point. I can go up to geometry right here, right, and grab that point. It doesn't look like that right now, but let's talk quickly about some of the visibility. If you right-click it and go to this little paintbrush here, it changes it to a couple of different visual settings. I'll show you some of those more, but right now it says TXT for text, where it always draws the name. Well, it already was, but now you can see that that actually is a point, right? Even though, well, I mean, I told you it was a point before, but then you can go back to that. But what I'm going to do, and this is very, very important, is I'm going to leave it on text because I'm going to name it as a certain type of connection. So for this one, if you right-click it, I can go to, I can call it Earth Origin. And I'm going to plug the point, not the sphere, I'm going to plug the point of the Earth's origin into my Earth origin param. Now, what makes it really cool, and this I think is kind of cheating in a way because there's no real way to create this kind of connection without just duplicating information. So if you copy Earth origin and then override that connection from Earth origin to Earth origin. I know it seems really counterintuitive right now, but you'll see why it's really cool in a minute here. Earth origin to Earth origin. So right now, read the information, right? It's a point coordinate 10, 0, 0. The next one, Earth origin. It's a point coordinate 10, 0, 0. The next one, Earth origin again. It's a point coordinate at 10, 0, 0. So it's duplicating that information. But the reason we're doing it is this. If you right-click it and you go to Wire Display, you can change it to a hidden wire display, which puts this little Wi-Fi symbol on the edge.
Oh my God.
Yeah, it's super powerful. So now I can take that and push it over to my origin. Right, so this sits here as sort of a sign that says I have this information going off somewhere else. And then this one now can override that connection. And it still creates the point at the Earth origin. So when you select either one of these, you'll see that there's that green line that shows up. That green line is showing you where you have wireless connections. So you can follow it back if necessary. But now you have this verbal declaration that says this Earth origin is plugged in somewhere else. So you can go and find it like this. Okay, so 15 minutes and all we did was drop in 2 different components, but I think it was really valuable 15 minutes. Okay, you'll see why once we start dropping in a whole bunch of these. There'll be a lot. Okay, questions? Okay.
Disconnecting the wires?
Yes. Sure. Yeah, I'll recap on disconnecting wires. So again, for all of you guys who may have missed it or need a refresher, to disconnect a wire, if I accidentally connect maybe a sphere to that instead, just right-click at the input and go to disconnect. Oh, look at that. I went on the wrong side. Right-click, go to disconnect, and it'll allow you to select which of the inputs you want to disconnect. In this case, it's only one. Otherwise, the other way is if you hold Control at the input or the output. At the input, you just go backwards with the wire, and it'll take it off. Okay.
And how did you do the annotations that lets you know the operations you follow?
Sure. That's a good question. So again, another one for you guys, another reminder here. If you want to add in a little bit of text like I do, there are 2 ways of doing that. You can make it a group. So select the object that you want to make a group of, and then right-click it and change the title of that group. So I can call this one vector, what was it under? Vector grid, vector point, plane. There you go. So you can do it that way. That's one way. Another thing that you might want to, keep in the back of your mind at all times is if you go to Params and under utility, this one's pretty cool. I'll show you a few of these in a little bit, but scribble is a neat one because you can drop it into space like this and leave reminders for yourself. So you can say leads to equator rotation or something like that, which is what it's going to do. Useful, right? Under params and utility. I don't think I can group that one, can I? Oh, I can. Cool. All right, and then there's one more that some of you might have guessed already. You can use a panel. Panels don't have to be used for information. You can just put it right here and say, comes from origin of Earth at start. Okay? All right, so that was a very long video. Sorry to do that to you guys, but I think it was super valuable information.